Okay, here's section 3.7, exercise 8. And here they're just describing some numbers. They say the sum of the first number squared and the second number is 54, and the product is a maximum. Okay, so we're supposed to find two numbers. Okay, find an x and a y. And we want to maximize x times y. So again, the problem is that that could be anything, and actually if there are no constraints on these, right, the answer is infinity. But this is subject to, and they say the first number, we'll call the first number x, so the first number squared plus the second number is 54. Okay, so I will use that constraint and solve for y. So I have y equals 54 minus x squared. Toss that into our maximization there. So maximize, I'll call it z, equals x times 54 minus x squared. Now this is unconstrained. We can let x be anything we want. I don't think this ever said positive numbers. No. So this is an unconstrained optimization problem. First thing, find those critical numbers, z prime. Oh, well, let's make that 54x minus x cubed. So I get 54 minus 3x squared. I want to set that equal to 0 to find my critical numbers. So I have 3x squared equals 54. X squared equals 3 goes into 54, I think 18 times. Is that right? 24, 54, yeah. And so x is equal to the square root of 18, which is, well, actually plus or minus, the square root of 18. And that is plus or minus, well, that's the square root of, that's 9 times 2 in there. So that's 3 times the square root of 2. Okay, so there are my two possibilities. And, well, let's check concavity. Z double prime is minus 6x. And so I see that if I want to maximize, I want the positive 3 times the square root, right? Because z double prime of 3 times the square root of 2 is equal to negative 18 times the square root of 2, which is less than 0, which says concave down. And then z double prime of minus 3 square root of 2 is 18 square root of 2, which is greater than 0. That's concave up. And so this is what we would like. And so it says one number, x equals 3 times the square root of 2. Now, if that's the case, then x squared is 18. We had that before. And so y is 54 minus x squared, which is 36, I think. 54 minus 18 is 36. So x and y are 3 times square root of 2 and 36. And and then the product, so if we look at our product, what did I call it? Z. Z equals x times y. That is 3 times square root of 2, all times 36. Well, let's see, 36 times 3 is 90 plus 18, so that's 108 times the square root of 2. Okay, and since square root of 2 is 0.4, 1 something, this is, you know, somewhere around the number 40, 43 more than that or so. So the product is somewhere up around 150. And now we can check this pretty quickly. So we wanted to maximize that. So let's just go take a look at Desmos real quickly to check our answer. It all looks pretty good. X times 54 minus x squared. Oh, well, and actually, before I do that, let's just point out, you know, we have a 0 at 0. And 0's at the square root of 54, so plus or minus, so that's out here somewhere. And if I put in a 1, I'm positive, and so, you know, I think we're going to see a function that looks like that. And so let's go to Desmos. Desmos, we can get rid of a bunch of this stuff. This is all holdover from another one. So we'll go F here, and that was x times 54 minus x squared. And sure enough, it looks like now this is a pretty ugly picture that way, so what I'll do is let's see, what's that 0? It's 7.3. So I'll go here and kind of leave the y-axis alone, but go to the x-axis and go from, say, minus 10 to 10. And when we do that, yep, there's the picture I thought we would get. And you know, going here, we can check our maximum. And we had the answer, what the heck was our answer? X was 3 times the square root of 2. So I can check 3 square root of 2 is 4.24, and again, when I was here, that was 4.24, 4.243. And so we got it. There is the maximum, and it is indeed at x equal the square 3 times square root of 2, and y then equaling whatever the heck that was, 36. Okay, so that was exercise 8.